component in a vector and magnitude of a vector. So for component, so when I say the word component, just think about this. You treat a vector as a machine. Components in a vector is like you open up the shell of the machine and then you look inside the parts of that machine. So the part stands for the component. So for a vector, we divide that into 2 dimensions and 3 dimensions. So for a 2-dimensional vector, each vector has 2 components, a1 and a2. For a 3-dimensional vector, each 3-dimensional vector has 3 components, a1, a2, and a3. So we have a vector A. So do you see that there is an A with a arrow on top of that? So we have 2 components, a1 and a2. We store them in an angle bracket. For 3-dimensional, we have a1, a2, and a3 in an angle bracket. So for a1 and a2, so let's say we have that. So let's say we have angle A. Not angle A. So vector A. So let's say we have that is 2. How about 4, 2? So 4, 2. So we have 2 components, 4 and 2. That means you go 4 units to the right and 2 units up. So that's how you think about the component. Of course, for 3-dimensional, the graph is a lot more complicated. So you have a vector A, and then there are 3 components, a1, a2, and a3. So from the initial point to the terminal point, the component tells you where to go, right? So for the 2-dimensional, the initial point is at the origin, so from 0, 0, so the component is 4, 2, so you go 4 units to the right and then 2 units up. Let me give you an example right here regarding the component. So for the simplicity, I will just use 2 dimensions. So in this graph, in this xy plane, I have 2 vectors, orange vector u and a green vector v. So the orange u starts at 0, 0 and then terminates at 3, 2. The green vector starts at 1, 3, terminates at 4, 5. So the first observation that I see here is the u and v. These 2 vectors, they have the same direction and same magnitudes. That means they have the same length and they are going to the same direction. So how do you find the components of vector u? Because take a look at vector u, the orange vector. There are 2 points, right? A starting point and a terminal point. So starts at 0, 0 and then terminate at 3, 2. So when you find the component, you take the terminal point minus the initial point. You take the x minus x, the y minus y. So the terminal point, the x is 3, the initial point, the x is equals to 0. So that's why you have 3 minus 0. So this one is just like x2 minus x1 and then y2 minus y1. All right, so x minus x, y minus y, always terminal minus initial. All right, always terminal minus initial, and then 3 minus 0 is equals to 3, and then 2 minus 0 is equals to 2. So that's how I know for this vector u, there are 2 components, 3, 2. So that means you go 3 units to the right and then 2 units up. And then what about vector v? So for vector v, you have x minus x, terminal minus initial, which is 4 minus 1, and then the y is 5 minus 3. So the components in vector v is 3, 2, right? So I know that starting at 1, 3, I have to go 3 units to the right and 2 units up. So they have the same direction, and then they are going to the same, they have the same magnitude, and then they are traveling to the same direction. So that's why I said vector u is equals to vector v. So let me give you a general formula. One for 2 dimension and one for 3 dimension. Again, just remember that we are taking the terminal minus the initial. So suppose the initial point is point A and the terminal point is point B. So the initial I call the x1, y1. The terminal point I call the x2, y2. And then we have a vector AB. So the components in vector A, so we take x2 minus x1 comma, and then y2 minus y1. And then for 3 dimension, the only difference is you have x, y, z in the initial and the terminal. So for when you look for the component in the vector, then you take x2 minus x1, y2 minus y1, and z2 minus z1. Just remember that you always take the terminal minus the initial. The math is easy. That sounds very complicated, but the math is easy. Just take the terminal minus the initial, and then you can look at the component of a vector. And then the magnitude is even easier. So the magnitude means the length of a vector. So for 2 dimension, all you have to do is you square every component of a vector. So for 2-dimension vector A, I have A1 and A2. So all you have to do is you take the square root of the square of A1 plus the square of A2. And then the magnitude, they use an absolute value. I don't think you can call that an absolute value. So when you say magnitude of a vector, it has nothing to do with the absolute value, but you still use the absolute value symbol. All right, and then for 3 dimensions, so all you have to do is inside the square root, you also add the square of A3. So that's how you calculate the magnitude of a vector. And then in the next video, I will give you some example regarding the components and magnitude of a vector. I see you all in the next lesson. Signing off for now.